So are you able to hear me now? I think there's some issue with the mic. I just corrected it. I'm just checking. Okay. So now I'm able to see properly. Fine. So let's start with the first chapter, which is real numbers. So what is the real number chapter means? Here in this chapter we're going to cover mainly few questions that is related to rational numbers, and then LCM and HCF are the main topics from this chapter. And we also have the other type of questions like case study questions can be coming from this chapter, where we have to consider whether it is LCM or HCF type of question, and then we have to solve it. Okay, so the first chapter from real numbers is so main important formula from this chapter we'll cover first, and then we'll go on one by one. So first, real numbers means you have to understand that we have different types of numbers. First one is natural numbers, which starts from 1 to infinite are the natural numbers. Then we have whole numbers, which starts from 0 to infinite. Then we have integers, which starts from minus infinity to plus infinity. And then we have rational, which represents as q, which is represented in form of p by q. And we have irrational numbers, so which cannot be written in form of p by q. For example, pi, e, or even root 3, this comes under irrational numbers. So all this comes under real numbers, whereas imaginary numbers also we have it, which we have to written in form of complex. So but for 10th class we don't have the imaginary numbers, so whichever, all this comes under real numbers. Okay, it is something like this. We have n, above it we have w, above it we have z, on this we have q, and then we have I as well. Irrational numbers, okay, it is represented as q dash, sorry, not I. Okay, so these are the numbers which if they ask you whether it belongs to integer and all, we have to understand, but mostly just remember, if it is written, if we can write in terms of p by q or numbers or integers or whole numbers, all belongs to real numbers. So main important questions which will be coming from this chapter is, they will ask you to prove that root 2 is irrational. They can ask you in this way, or they can also ask you to prove root 5 as irrational, or root 2 plus suppose 2 is irrational. These type of questions will be coming. So the details how to solve it, the hint I will provide you, just write. First we have to assume whichever they provide as rational, and then convert into p by q, do cross multiplication and so on, and finally you have to okay, yes, and then we have to, at the ending we have to prove that our assumption is wrong, that so root 2 is not rational, so it is irrational. Okay, in detail, as I mentioned, when I am covering the real numbers revision, I will cover in detail. So this is one of the point. They can ask you these steps. They will ask you to prove root 2 as irrational, root 2 is irrational, so on. Okay, so in detail we will cover it. Next important question from this chapter, because in this video I don't want to cover the questions, I just want to only cover the formulas only. So main formulas which will be coming from first chapter are LCM and HCF. Okay, so for this I will give an example. I will just take three small numbers 12, 15 and 21, how to solve it for LCM as well as HCF I will explain. So mostly of the cases I will use prime factorization method. So what is prime factors means, you have to write in this way, like for suppose 12 is present, so just solve it using the least prime number, which is 2. 2 6 are 12. Next 2 3 are 6, 3 is also a prime number, so 2 3 6, so 12 I can write it as 2 into 2 into 3, whereas 15 I can write it as simply 3 into 5, and 21 is again easy, which is 3 into 7. So for LCM what we have to do is write all the prime factors which are present here. So what are the prime factors present here? 2 3 is present here, already 3 is covered, so I'm not writing 3 again. Then we have 5, then we have 7. So what is the highest powers of all the prime factors? For 2 it is 2, for 3 5 and 7 it is only 1, so this is nothing but the LCM, which is 4 into 3 12, 12 5 is 60, 67 is 420. For HCF, what we have to do is just take only the common prime factors for all three. So here the common prime factors is 3. You can see which is present in all three. So here the HCF is 3. Okay, I'll give one more question. So let's take only two numbers now, because I want to tell one more important point for two numbers. Let's take for 10 and 15. So for 10, how can I write in prime factors? It is 2 into 5. For 15, how I can write in prime factors? It is 3 into 5. So let's solve LCM first. LCM, as I told you, first write all the prime factors. Here 2, 3 and 5 are the prime factors. So just write all 3. And here the highest power is only 1. So simply 6 5 is 30 is the LCM. Whereas HCF, what I told you, just see whichever is common. Here only 5 is common in both the numbers. So HCF is 5. Okay, so why I have taken only two numbers? Because one important condition, this is most important for 1 mark as well as for 2 marks questions. The concept is for two numbers. Always remember, only for two numbers LCM into HCF is equal to product of the numbers. This is very important. I am saying it will definitely come for MCQ or at least for a very short answer questions as well. Okay, the concept is for two numbers LCM into HCF is always equal to the product of numbers. For the same example, here also it is two numbers. So what is LCM here? LCM we got it as 30, HCF it is 5. The product of numbers 10 into 15. So what is 10 into 15? 150. 30 into 50 also 150. You can see both are correct. That is LCM into HCF of two numbers is always equal to the product of the numbers. Okay, this is very important, and how to solve LCM and HCF I have covered. So these are the main concepts for from the real numbers chapter. Okay, one more. So I can ask you, what is co-primes? So primes we know, composite we know. Primes are the numbers which have only one and itself as a factors. Composite means which are not, if you are having more than two factors are composite. What are co-primes? Co-primes are two numbers which does not have any common factor. And repeating again, so co-primes are the numbers. It's not like they are prime numbers. They are numbers, any numbers, prime or composite, but which does not have any common factors between them are called co-primes. For example, if I say 6 and 9. Okay, 9 has number. Okay, 6 and suppose 5. Okay, these are co-primes. 6 is a composite number, but still 6 and 5 are co-primes. Why? Because this does not have any common factor between them. So let's say another example. Suppose I have 12 and suppose I have 15. I have another number. Okay, 23. So here does not have any common factors between them. So all the any numbers, two composite cannot be co-primes, because at least one of the prime factor will be there in common. So one prime and one composite, there can be cases where it does not belong to prime numbers, like where it belongs to co-primes. Co-primes, as I mentioned, which does not have any common factor between them. Okay. So I think yes, most of the cases from real numbers will ask you only these things. They will simply ask you, check whether these two are co-primes, check whether this is belongs to integer, check whether it belongs to real number, check whether this is prove that it is an irrational. That will come for 2 marks or even 3 marks questions. And for 5 marks also they can ask you, if they clearly mention to first prove that root 2 is irrational, also prove that 2 plus 2 root 3 is irrational. Such type of question they can ask you for 5 marks. But mostly from this chapter you will get hardly 5 to 6 marks from your main exam. Okay, this is from real numbers. Let's go to the second chapter. Second chapter is polynomials. So poly means multi, like any equation which is having single, double or triple comes under polynomials. So polynomials, if we have to, first important point is degree. So what is degree? Means highest power in the equation. For example, if I have equation stating x plus 2, so here the highest power, if it is nothing mentioned, you have to assume it as 1. So here the high degree is 1. If the degree is 1, we call it as linear equation or linear polynomial. If the degree is 2, for degree is 2 means it should have the highest power as 2. So here the degree is 2 and we call this as quadratic polynomial. Then we have third one, which is cubic polynomial. So here the degree, highest degree should be 3. So for linear, if they ask you, this can be important for MCQ point of view, they will simply give you the equation. They will ask you whether this is linear, quadratic or cubic. So if the highest degree is 1, then it is linear. If highest degree is 2, then it is quadratic. If highest degree is 3, then it is cubic. You have to remember all three equations. So this is degree. What is the degree? Means highest power in an equation is called it as degree. So is it clear till here? Okay, so let's move to the next topic of second chapter. This is zeros. They can ask you the question to find how many zeros are present. So zeros of a polynomial are simply how many times the graph is intersecting x-axis. So how many times the graph is intersecting x-axis, those many zeros are present. For example, if I have a graph like this, then how many times it is intersecting the x-axis? We have 1, we have 2 and we have 3. So here the number of zeros is equal to 3. The same type of graph, if suppose I tell you the graph is like this, then number of zeros, can anyone answer how many number of zeros now? The answer is 0 because it is not intersecting with any axis. Okay, similarly, let's give one more. Suppose I have a graph like this. I want the persons or the students who is watching the video to answer this question. C and D, how many number of zeros are present? Okay, I want for C and D number of zeros. Okay, you can answer it later when you are watching this video. Zeros for here as well as here. Okay. So zeros are done. Then for quadratic and cubic, we have one formula here, that is sum of zeros, product of zeros formula. So let's see those two formulas now. For quadratic equation, the general syntax of the general equation is ax square plus bx plus c. This is the general equation for quadratic equation. So if I say sum of zeros, so how many zeros are present for quadratic? So maximum, what is the degree, the millions of zeros will be present. So here the degree is 2, so the zeros will be 2. Zeros at maximum can be 2. So here sum of zeros is alpha plus beta, the zeros here. Sum of zeros formula is minus b by a, whereas product of zeros is c by. Okay, sum of zeros of quadratic equation formula is minus b by a, whereas product of zeros of a quadratic equation is c by a. Okay, this is for quadratic. So for example also I will just provide you here. If I say 2x square plus 3x plus 5, this is a quadratic polynomial, then alpha plus beta will be minus 3 by 2 and alpha beta, that is product of zeros, will be 5 by 2. Okay, let's see for cubic polynomial. For cubic polynomial, what are the zeros? I mean sum of zeros and product of zeros. For cubic polynomial, the equation is like this: ax cube plus bx square plus cx plus d, because the highest power should be 3. So here the sum of zeros, that is alpha plus beta plus gamma, is a third root. It is minus b by e, whereas like this alpha beta plus beta gamma plus gamma alpha will be c by e, whereas product of all the zeros is minus d by. This is present in NCERT, so I suggest you to remember this formula as well. So there can be cases where you can also get this type of question. They will simply give a cubic polynomial. They can ask you what is product of roots, what is sum of roots, and so on. Okay. So yes, most of the part of polynomial chapter is done. Let's move to the third chapter, important formulas, which is pair of linear equations in two variables. So the name itself, it is saying that it is a pair of linear equations, that is two equations, and in two variables. Two variables, we have x and y as the two variables. So it will be something like this. We have a1x plus b1y plus c1 is equal to 0 is first equation. a2x plus b2y plus c2 is equal to 0 is the second equation. This is first equation, this is second equation. As this is having two equations, we call it as pair. And why it is two variable? Because we have two variables here, x and y. So in this way you have to understand what you are doing first of all. Okay, so here the pair of linear equations two variables means we have two linear equations, that the highest power is only one, and it is of two variables because we have x and y as the variables. Okay, so what is the main first important formulas for third chapter is we have to understand whether these two lines are intersecting, that is connecting each other, parallel, there is no point of intersection, and collinear. Collinear means on the same line. So we have three: intersecting, parallel, and coincident. So for intersecting, what is the condition means a1 by a2 should not be equal to b1 by b2. For parallel, a1 by a2 should be equal to b1 by b2, should not be equal to c1 by c2. For coincident, a1 by a2 should be equal to b1 by b2, should be equal to c1 by c2. Okay, so this I will explain by keeping two examples. So let's see, I have an equation like this: 3x plus 2y plus 5 is equal to 0 is first equation, and 4x minus y plus 6 is equal to 0. Suppose I have second equation. So let's see what is a1 by a2. So a1 by a2, I'll write it here: b1 by b2, c1 by c2. a1 by a2 is 3 by 4, b1 by b2 is 2 by minus 1, c1 by c2 is 5 by 6. So if I notice, a1 by a2 itself is not equal to b1 by b2, so these two lines are intersecting. Okay, so if it is intersecting, I have how many number of solutions? Okay, I will write it here. For intersecting, okay, draw a line so that you will not get confused. Okay, so for intersecting, number of solutions is 1. For parallel, number of solutions are 0. For coincident, number of solutions are infinite. Okay, this is for solutions. So as it is intersecting here, number of solutions is equal to 1. So and then we have next concept, which is consistent. So how to find consistency means, if it is having solution, if solution is present, lines are consistent. So simply for intersecting and coincident, the lines are consistent, whereas for parallel, lines are not consistent. Okay, this is important for 1 mark and 2 marks concept, because they will simply give you two lines. They will ask you to find whether the lines are consistent or not. They will simply give you two lines, and they will give you some constant, and they will ask you to find this constant value if these two lines are parallel. So simply you have to just relate this ratios values and then get the values. Okay. So next important formulas for not formula, the methods for this chapter is, we have to remember to solve pair of linear equations. We have three methods. First one is graphical method, then we have substitution, and then we have elimination methods. So we have to cover all three methods to solve this type of questions. So graphical questions, there can be cases to get the 5 marks questions as well. For substitution and elimination, you might get 2 marks or 3 marks questions. Okay, so in detail I already covered in another video with the help of examples. So this you can check, and respectively you can solve these questions. Okay, I'm not going, because these are not formulas, these are methods. So in detail the methods, it's better to solve with the help of questions itself. So I will keep that link in the description. You can refer to that link, and if you have any doubts, you can mention in this comment section. Okay, then we have, let's go to the next chapter, which is quadratic polynomials or quadratic equation. So the intro of this quadratic we already covered in second chapter. So quadratic is nothing but the highest degree is 2. Okay, so highest degree 2 equations are present. We have to solve them to get the zeros, or we also call them as roots. So one example I will provide you here. If I suppose I have an equation like this, x square minus 4x plus 4 is equal to 0, they will provide you, and they will ask you to find the zeros of this, zeros or roots, we can call it anyway, zeros or roots for this quadratic polynomial. Okay, so for quadratic equation chapter, we have two methods to solve this equation. First method is, we can either solve using prime factorization method, or you can solve using quadratic formula. Okay, I will going to cover both the methods now. So for quadratic formula, the method is minus b plus or minus root of b square minus 4ac by 2a is the quadratic formula. Prime factorization method, I will help you to how to solve it. Okay, for this question we will solve in both the ways. So let's solve it. X square minus 4x plus 4 is the equation. So for quadratic polynomial, what you have to do is, first write a into c. A here is, okay, I will just compare with ax square plus bx plus c. So what is a value? A value is 1, because there is nothing here. C value is 4. 1 into 4 is 4. So what are the factors of 4? 1 into 4 we have, and 2 into 2 we have. So using any of these combinations, you have to get the b term. Okay, so if I add or delete 1 plus 4 or 4 minus 4 or 1 minus 3, we will get only 5 or 3 here. So it doesn't matter, but we want 4. So if I check for this point, minus 2 if I do, I will get as minus 4. Okay, so that's when now I can change this equation as x square minus 2x plus 4 is equal to 0. If I take x as common here, it is become x minus 2, and minus 2 as common becomes again x minus 2. Always remember this part and this part should be equal. Okay, so now this will be x minus 2 into x minus 2 is equal to 0. So x minus 2 is equal to 0 and x minus 2 is equal to 0. So x values are 2 comma 2. Okay, let's solve using the quadratic formula, because in the question they can ask you in both the ways, either solve using prime factorization method or solve using quadratic formula method. Okay, so let's solve the quadratic formula method as well. So it is minus b plus or minus root of b square minus 4ac by 2a. So it is minus b. Minus b means b value is minus 4 here. So minus of minus 4 plus or minus root of 4 square minus 4 into 1 into 4 by 2a. So it becomes minus into minus plus 4. So a value is 1. So 4 plus or minus root of 16 minus 16 by 2, which is equal to 6 minus 16 is 0. So 4 by 2, 4 by 2 is nothing but 2. So only values which you have is 2. You can see you got the same answers using prime factorization method or quadratic equation method. So both the formulas are correct, but if they clearly mentioned you have to use only quadratic formula method, you have to use this one. If they mention prime factorization method, you can use this one, but if they haven't mentioned anything, you can choose whichever you feel is much confident. Okay, so next important formula from this chapter is regarding b square minus 4ac value. Okay, so with this we have three cases. If this is 0, then the roots are real and equal. If b square minus 4ac is greater than 0, then real and distinct. If b square minus 4ac is less than 0, we call them as imaginary. And this is important with respect to 2 marks and 3 marks, and even 1 mark questions also you can get it. They'll simply give you equation and will ask you to what is the nature of the roots of this equation, or else simply they can provide you the nature of roots are real and equal, then find the value of b. They give the nature of roots are real and distinct, then what is the condition? So simply just find b square minus 4ac value. If this value is 0, roots are real and equal. If this value is greater than 0, roots are real and distinct. If this value is less than 0, then the roots are imaginary. Okay, let's continue the point. So quadratic equations chapter is, yes, most of the topic is in, yes, this is one more. So sum of roots, product of roots are not going to cover here because this part we already covered in the second chapter, which is polynomial chapter. Okay, I'm going to the fifth chapter now, which is arithmetic progression. Yes, good evening, Harry. So let's meet with the fifth chapter now, which is arithmetic progression. So this is very important chapter because at least 5 to 8 marks will be coming from this chapter. Okay, you might get MCQs, 2 marks, 3 marks, and even 5 marks questions can be coming from this certain chapter. And even there are cases that you might also get case study question from this chapter as well. Okay, so that's why I'm saying this is very important chapter, and this is the most easiest chapter according to me because we have only 3 concepts from this chapter. If you just remember those 3 concepts and apply properly, you can easily solve these questions. So let's see the only 3 important formulas I told you. The first formula is, okay, let's suppose what is arithmetic progression is, you have to remember that it is in the form of like this: a plus d, a plus 2d, and so on. And the last name, let's write it as an. An is the nth term or the last term here. Okay, first important formula is common difference. Common difference means we have two, like n number of values. For AP series, what is the main criterion is each number will have a difference of only d. If you check here also, a and a plus d, difference is d. A plus d and a plus 2d, difference is d. Same way it will keep on going. So common difference d, if I want to find, I can simply subtract any two values like a2 minus a1. This can also be equal to a3 minus a2. This will also be equal to an minus a of n minus 1. Any two different consecutive values you can check it, and then just subtract into consecutive numbers, you will get the common difference value. Okay, second important formula from this chapter is Tn, and they can also solve you an, so which is nothing but nth term. Nth term formula is a plus n minus 1 into d. So a is the first term here, n is the nth term which they are asking, and d is the common difference. Okay, and then we have the third formula, which is sum of n terms. So for this we have two sub formulas I can say. So for sum of n terms, first formula is n by 2 into 2a plus n minus 1 into d. Second formula is n by 2 into a plus l, where l is the last term. Okay, if the question they provided you the last term and first term, you can directly use this formula to get the sum of n terms. If they're not provided you, then you can use this formula. But both are same. Why? Because this is nothing but n by 2 into a plus n minus 1 into d. So what is a plus n minus 1 into d? If you remember the previous slide, I have told you a plus n minus 1 into d is nothing but the nth term. Yeah, sure, Hari, I will do it, because first I just want to, as everyone has done the social exam today, I don't want to do more questions to get. So just for a revision point of view, I just want to teach all the formulas today. Okay, so I'll just mention the chart as well, same thing. Sure. So these are the main three formulas from this chapter. So let's go to the next chapter now, sixth one. So this chapter, okay, I will solve only one question for just for the practice. The question is suppose 2, 5, 8, 11 and so on. Okay, this is an AP. Why? Because the common difference is 3. So if I ask you what is common difference, it is 5 minus 2, which is 3. You can also check for 8 minus 11 minus 8 also it is 3. So if it is AP, definitely it should be common difference values. Then we have, for suppose if I ask you what is 7th term, A7. A7 means A plus n minus 1d is a formula. So A is 2 plus n is 7 here. So 7 minus 1, common difference is 3. So it is 2 plus 6 into 3, 18 plus 2, which is 20. So 7th term if they ask you, the answer is 20. So if they ask you what is the sum of 6 terms, S6 if I ask you, then I have to substitute the formula, which is n by 2 into a plus, okay, nth term I don't know, so I will just use this first formula, which is 2a plus n minus 1 into d. So it is 6 by 2 into 2 into 2 plus 6 minus 1 into 3. So it is 2 ones are 2 3s. 3 into 4 plus 5 into 3 is 15. 15 plus 4 is 19. 19 3 is a 57 is the sum of 6 values. Okay. So what I am saying, this chapter is very important. Definitely you will get 5 to 8 marks from this chapter. Okay. Just remember these 4 formulas at max. So just try to apply them properly. You will definitely get a full marks from this chapter. Okay. So let's move to the 6th chapter now, which is triangles. This I can say little tricky when compared to all the other chapters, this one and circles, because there can be little theorems based questions. At the same time, we have to just apply some logics to get the solutions. So I always suggest to keep triangles and circles at the last of your revision preparation. Okay, these two chapters are little tricky when compared to others, because these are not direct formulas you have to apply. You have to just think something and then solve the questions. Okay, so let's see for triangles chapter now. So triangles, first important thing is we have to remember BPT theorem. This will come for sure, BPT or inverse BPT. Okay, that is basic proportionality theorem or converse of basic proportionality theorem. It will come for sure. They can ask you directly theorem, explain the theorem, or else they can ask you, you apply this theorem and get the ratio of sides of values or something. Okay, so just BPT theorem formula I will just mention here. Suppose this is ABC is a triangle, and we have DE as a line, which is DE is parallel to BC. Okay, this is important. Then AD by BD is equal to AE by AC. This is simple BPT theorem, and how to prove it I will explain in the next videos. Okay, but here as I mentioned, it is only for the formulas videos. I'll just giving the formula. The converse of the basic proportionality theorem is opposite. Like, okay, now they'll say that in converse means if AD by BD is equal to AE by EC, then these two lines are parallel. Okay, so this is the easy theorems, BPT and basic proportionality, converse of BPT. The proof is very important, or proof also is important, because there are so many papers I have referred, they directly asked to prove the basic proportionality theorem. Okay, so that's why proof is important. At the same time, you have to know how to apply this theorem as well. Okay, so that is the first part of triangle chapter, and then we have the similarities concept. So what is similarity means? We have four types of similarities, which is angle similarity, angle side angle similarity, all three angles equal similarity, sides proportional similarity, the last one SAS similarity. Okay, if two angles of one triangle equal to two angles of another triangle, then first both the triangles are similar. Same way, okay, I'll write the triangles here. Suppose I have two triangles, then if suppose this angle and the corresponding side, this is important. Suppose this is 1, 2, and suppose this side is x, then there should be two angles, like suppose 3, 4, and the corresponding side should be proportional. Suppose y. Then the using ASS similarity, I can say these two triangles are similar. Always remember the corresponding side should be same or proportional at least. Okay, only in this case the side angles are similar, and this one both are same, because if two angles are equal, the other angle will also obviously will equal, because sum of all three angles is 180. Okay, so I'm not going to cover this. SSS is equal, like all three sides should be proportional. If I say 1, 2, 3 is sides of first triangle and 4, 5, 6 is the sides of second triangle, then 1 by 4 should be equal to 2 by 5 should be equal to 5, it is 2 by 5, and 3 by 6. Okay, all the corresponding sides ratios should be same, then you can say that both the triangles are similar. And the next one, two sides in one angle, that if these two sides are proportional and the respective angle is equal, then I can say that both the triangles are similar. Okay, so in this way all the four similarity concepts will be covered, but this using theoretical or reading will not be enough. We have to practice a lot to solve this type of questions. Practice is important or needed for this chapter. No theory, no reading. We have to write something, solve as many as questions from triangle chapter, then you can feel much confident. I'm saying this chapter will be tricky, definitely, for sure, because here we need to not like mugging. If you mug the formulas or something, we cannot solve this chapter. We have to practice a lot, think how to solve it, then only you can solve this chapter. Okay, we will keep this chapter at the last, but I will try to cover other chapters at the beginning itself. Okay, next we have the 7th chapter is coordinate geometry. So coordinate geometry is also again easy chapter. So here we have only two formulas. I can say, if in detail if you go, it is three formulas. Okay, so coordinate geometry means we have two things, x and y. X we call it as ordinate, and y we call it as abscissa. Okay, what are ordinate and abscissa means? We have two axes, x and y. So if suppose I have a point here, then what is this point means? What the distance from x axis is x, and the distance from y axis is y. So I will draw another graph, x and y, and if I say the point is 2, 3, then this distance and this distance, x value is 2, whereas y value is 3. Okay, so to mark any point on the graph, just remember first one is this is x axis, so this value, the x value is 2, whereas y value is 3. So this is first important, how to mark the points on the graph sheet. Then we have the formula here. First one, distance between 2 points So distance between 2 point formulas, so let's suppose the points are x1 comma y1 and x2 comma y2, then the distance between these 2 points is root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the main formula for distance between 2 points. This is very easy formula. So if I say I have points 1 comma 1 and 2 comma 5, then the distance between them is root of 2 minus 1 whole square plus 5 minus 1 whole square, which is 1 plus 4 square is 16. So root of 16 is the distance between these 2 points. Okay. Next we have the second formula from this chapter, which is if a point is dividing a line in ratio m is to n, or else, okay, I'll write the statement as well. Find the ratio in which x comma y is dividing line joining x1 y1 and x2 y2. So how to what is the formula means, we have here x1 y1 x2 y2, and suppose this is x comma y, then m is to n, for suppose I am considering it as a ratio, then x point I can write it as m x2 plus m x1, sorry, it is n x1 by m plus n, and y value is m y2 plus n y1 by m plus n. So how to remember, m is easy, m into the right side plus n into left side, m into x2 plus n into x1, m plus n, m into y2 plus n into y1 by m plus n. This is very easy formula. Same way, this formula, if suppose if m is equal to n, then the ratio is 1 is to 1. 1 is to 1 is nothing but midpoint. So what is midpoint formula means? x1 plus x2 by 2 comma y1 plus y2 by 2. Okay, this is for midpoint formula. If they tell you for ratio, you have to use this formula. X is m1 x2 mx2 plus nx1 by m plus n. Y formula is my2 plus ny1 by m plus n. Okay, then we have one more concept from this chapter, which is equidistant. So don't consider equidistant and midpoint as same, because this is different, equidistant. So what is, let's understand what is the meaning. Equi means equal, and what is equal here? Distance is equal. Okay, so if I say that I find a point, suppose here x comma y, which is equidistance from both the both 2 points, then this distance, which is, suppose this is d, then the same will be here as d. Distance from these 2 points should be equal to distance from these 2 points. Then I can say this point is equidistance from these two, this one and this one. Okay, I am repeating again, don't consider midpoint and equidistance as same. Midpoint can be different when compared to equidistance, because midpoint should be on the same line. Like the x and y are the same, this one and second point are on the same line, then if it is midpoint, then it is equidistance. But here if you notice, this is one line and this is another line. So it is not a midpoint of these 2 points, it is the distance is same. Like from here to here and from here to here, the distance will be same. That is equidistance concept. So simply just relate that, find the distance between these 2 points, that is x1 minus x whole square plus y1 minus y whole square is equal to the other distance formula. Then find the conditions. Okay, equidistance and midpoint, I am again repeating, both are not same. Midpoint is the line here and you have the midpoint here, whereas equidistance means the distance between these 2 points and distance between these 2 points should be same. Okay, so these are the main formula from the coordinate chapter as well. So all the formulas from all 7 chapters, first 7 chapters has been done. So in the next video I will cover the important formulas from 8 to the 14th chapter, or the last chapter, whichever is the statistics or probability chapters. Okay, we'll cover mostly tomorrow afternoon or tomorrow night. We'll get this video, which is from chapter 8 to 14 important formulas. Okay, so just revise all the formulas once again, because from tomorrow or day after tomorrow we will be having live sessions where we'll having all important questions, not formulas. Okay, all important questions will be covered in the next live or long videos, whichever is possible. According to my time, I will just do it. So all important questions means 2 marks, 3 marks, and even 5 marks questions will be covering for practice for your exam. Okay, so just wherever you have time, just prepare well, and thanks you for watching till end. So hope we'll meet in the next video. Thank you. Yeah, thank you, Hari, for joining.